In section 3, we start to get into solving quadratic equations. And the first way that we're going to solve quadratic equations is by graphing. So you could actually look at a graph and see where the solution is. We haven't done this yet this year, but it's kind of a straightforward thing. So take a look at these three parabolas that I have on the screen right now. What's different about all three of them? They're all moved around? Yes, that's what I was asking for. So they're actually, all three of them, the exact same parabola. It's just that some of them, like this one starts off lower down here, this one kind of starts off right here, and this one starts off up here, okay? The solutions to a quadratic equation are on the x-axis. So in this case, this parabola crosses the x-axis how many times? Twice. Which means that there are two real solutions. And we do have to start using this word real, because it is possible for there to be solutions that are imaginary, meaning they don't exist. But we do still have to find them, and we do that in Algebra 2. So we find things that don't exist in Algebra 2. They're called imaginary solutions. Every parabola has either two real solutions, meaning the parabola crosses the x-axis twice, or one real solution, meaning that what is sitting right on the x-axis? What is that? The vertex just sits right on the x-axis right there, which means that this parabola just touches the x-axis at the vertex. Only one time there. Or, in this case, does the parabola even touch the x-axis here? No, it never does. So that's why there are no real solutions. So where the graph crosses the x-axis is our solution. If it crosses twice, then we have two solutions. If it crosses once, then fine, we only have one solution. If it doesn't cross at all, then we have no solutions that are real. All right, we have a bunch of definitions that we need to write down here. And they're all wildly different from each other, so make sure you're paying attention. The first one is a quadratic equation. A quadratic equation is just an equation that can be written in the form y equals ax squared plus bx plus c. And that's just what we've learned already in this chapter. We're using the equation that looks like y equals ax squared plus bx plus c. A, b, and c are what? They're just numbers, right? X is what? A variable. Okay. Now, roots of the equation. So this word roots, you'll hear me say roots sometimes. You need to know what that word means. The roots of the equation are where the graph crosses the x-axis. That's it. So it's basically what we were just talking about on the last page. Roots of the equation are where the graph crosses the x-axis. Zeros of the function. So this is the equation right here. Or I could call that a function also. It is a function. When I graph it, it passes the vertical line test. So that makes it a function. So the zeros of the function, you'll hear me say zeros. You might hear me say roots. You might hear me say zeros. The zeros of the function are where the graph crosses the x-axis. You might hear me say x-intercepts. We know what the y-intercept is. What's the x-intercept? Well, the x-intercept is where the graph crosses the x-axis. And on the last page, I was asking you to tell me where the solutions to the equation were. The solutions to the equation this time are where the graph crosses the x-axis. In other words, these four things right here are exactly the same thing. All of them mean the same thing. Where does the graph cross the x-axis? If I ask you to find the zeros, or if I ask you to find the roots, or if I ask you to find the x-intercepts, or if I say what are the solutions to this equation, all of them mean the same thing. Find where the graph crosses the x-axis. That's it. To find the solutions to an equation, let y equal 0. So you'll turn this y, like you'll turn this y right here into 0. And then graph the equation as is. What you're doing is you're saying when y is equal to 0, where is the graph? So if I have a coordinate system like this and y is 0, 0 on the y-axis is right here at the origin. Where is the graph? Well, the graph is going to be on the x-axis. So once again, you're looking for where the graph crosses the x-axis. This idea right here is the entire section. So, let's do some practice problems. What are the solutions of each equation? Use a graph of the related function. So all we're doing is we're looking at the graph, and what are we trying to find? Where the graph crosses the x-axis. Yeah. Notice right here it says, what are the solutions? They could have said, what are the zeros? They could have said, what are the roots? They could have said, what are the x-intercepts? All of them would have been the same thing. We need to find where the graph crosses the x-axis. So, they give us this equation, x squared minus 1 equals 0. This equals 0 right here means that they turn the y into 0, and now we're trying to find when y is 0, which means right here, what value of x is where the graph lives. So right now, we have a 0, or we have a solution, or we have an x-intercept, or we have a root right there, and we have another one right there. What are those two values? X equals what? 1, and x equals negative 1. And that is it. How many answers do you have on this problem? You have 2 answers. Because the graph crosses the x-axis how many times? Twice. On this one, x squared equals 0. We've worked with y equals x squared before. That's the parent quadratic function. It's the parent parabola. The vertex is at 0, 0, and then it goes up from there. With that minus 1 right there, that shifts the parent parabola down 1 unit. And there you go. There's the vertex, and then it goes up from there. So what are my solutions here? X equals 0 is the solution. It is x equals a number. It's not just a number. Kind of like the axis of symmetry is an equation. These solutions, x equals something. When we were solving equations back in like chapter 2, the answer was x equals 4, for example. Okay? It's still x equals here. How about here? Yeah, the graph does not cross the x-axis at all, which means we have no real solutions. You do have to say the word real because we're to a point now where we can almost understand this idea of something imaginary that we have to talk about. So no real solution, and then if you want, there's a symbol for no solution. Do we know what that symbol is? I think we've talked about it. Yep, it's the circle with a line through it. That stands for no solution. So if you were to write that, I would understand what you mean. So now notice the directions here. It says solve y equals x squared minus 2x minus 8. And then they give us a grid. So we're going to have to graph this now ourselves. So we have to come up with the full graph. What will the graph look like? Will it look like a line? Will it look like a can of soup? It's going to be a parabola, okay? I know it's going to be a parabola because it's a quadratic equation. We have an x squared term. So I'm going to graph it. It's going to be a parabola. And then what will I be looking for? Where it crosses the x-axis, because the directions say solve, which means we're looking for the solutions, which means we're looking for the zeros, which means we're looking for the roots, which means we're looking for the x-intercepts. And all of those mean where the graph crosses the x-axis. So from last section, how are we going to graph this thing? What's our first move? AOS. Good. So axis of symmetry. What's the equation for that? It is x equals, at no time did I ever not say x equals, so you need to be saying x equals what? Negative b over 2a. All right, so now we can enter that stuff in. What do we write? Good. Negative, and then b is negative 2. Divided by 2 times 1. All right, so we have, what's the top? Positive 2. And what's the bottom? Positive 2. So that reduces probably to 1. So the axis of symmetry is x equals 1. I go over to my graph. Notice the scale. So 1 seems to be here. Do you agree? Okay, so we'll draw in that dotted line at 1. Which way does this parabola open? It opens up. Good. Now what do we do? You got to find the vertex for sure, but how am I going to do this? I should probably make a... Yeah, we got to make a table. X squared minus 2x minus 8, and y. And you guys said we got to find the vertex, so I'm definitely plugging 1 in. What else should I do? Choose numbers, one side or the other. Which way do you want to go? The positive direction? Okay. One thing I want to point out to you is the origin is sitting right here, and we know what ordered pair goes there. What is that going to be? What? Negative 8. We know that the y-intercept is already right here at negative 8, which means we know that we can reflect that dot over the axis of symmetry, and that will give us this dot right here. What number is that? Which x-coordinate is that right there? If I go back up here, what is that? It's 2. So do I need to find 2? No. So I can skip 2 and go on to 3. Then what? 4. And if I need to, maybe 5. So I take the 1, plug it in. First term, what do we get? 1. Next term? Minus 2, minus 8. What's 1 minus 2? Negative 1 minus 8. Okay, negative 9. And let's plug in 3, first term. 9. Second term. Minus 6, good, and then minus 8. So 9 minus 6. 3 minus 8. Negative 5. All right. And 4. First term. Yep. Next term. Minus 8. Next term. Minus 8, which is 0. And on my graph, that just gets me back to my x-axis. I still need all this space up here, so let's do one more. Let's do 5. 25, minus 10, minus 8. It's 7. Yeah, good. All right, that's probably enough. So we have the vertex 1 comma negative 9, which is there. We have 3, negative 5, so here's 3, and then right here's 3, and then negative 5 is there. It's okay that we're not on grid lines. And then 4, 0, and then 5, 7, 5, and then 2, 4, 6, 7. And now what do we do? Reflect. So we got to go 1, 2, so 1, 2. And then 1, 2, 3, so 1, 2, 3. And 1, 2, 3, 4, so 1, 2, 3, 4. There's my parabola. Now what? Okay, drawing the smooth curve. The graph is now done. But what is it we're supposed to be finding here? Where it crosses the x-axis. So now you need to be looking right there and right there. That's where the graph crosses the x-axis. So now you have to say where that is. So you write x equals, what's one of them? 4. We actually found that one right here. When x is 4, we get 0 for y. And x equals, what's the other one? Yep, negative 2. So those are the two answers. That's what I'm going to be looking for. I need the graph to be correct, and then I need the answers to be correct as well. Same type of problem here. What should we do first? AOS. So tell me what to do. X equals. Negative b over 2a equals. Negative negative 4 over 2 times 1. Okay, now simplify that. That is positive 4 over 2, which is 2. So we have x equals 2 as our axis of symmetry. What should I do next? Draw it in. So I go over to 2. Notice the scale this time. A little bit nicer scale than last time, so that's nice. Here's 2. Draw it in. Now what? Table, good. So I set up my table, x squared minus 4x plus 3, y. Okay, now what? Pick numbers. Which way do you want to go, left or right? I know which way I want to go. You want to go left? You want to Beyonce this? No, just go left. Yeah, I would prefer to go left also because 1 is an easy number to work with. 0 we already know. And negative 1, I just got to be careful about that negative sign and I'm good. 1 is easy to work with, so I'm going to go to the left. 1, well I have to do what? I have to do 2, and then 1. 0 I already know, and maybe I need negative 1. What is 0? It's 3. So I can just put that on here right now. Okay, let's plug in 2. First term. 4 minus 8 plus 3. 4 minus 8 plus 3. Negative 1. Okay, plug in 1. 1 minus 4 plus 3. 0. Good. And then plug in negative 1. that's 1, plus 4, because negative 4 times negative 1 is plus 4, then plus 3. That is 8. Good. All right, so we have 2, negative 1. 2, negative 1. There's my vertex. I have 1, 0. There you go. I already knew that one. And then I have negative 1, 8. So negative 1, there's 5. So 8 is going to be like 6, 7. It's way off my page. So I'll just put a little dot up there so that I have something to shoot for as I draw in my smooth curve. Now what? Reflect. So reflect over. 1 and then 1. 1, 2. So 1, 2. And then 1, 2, 3. So 1, 2, 3. Now what? Draw it in. Nice, good looking parabola here. There you go. Now what? Good. Where does the graph cross the x-axis? X equals what? And 3. That's right. There you go. There's your 2 solutions. So remember that I was saying in the beginning, you turn the y into 0. So this equation winds up being like 0 equals x squared minus 4x plus 3. This is something that does come into play here pretty soon. It's kind of an important thing. Like as in, comes into play right now. So maybe I had this equation x squared minus 36 equals y. To solve the equation, I turn y into 0, and then I wind up with this situation right here. Or I had this equation, maybe that was y equals 3x squared plus 15. So then I turn y into 0. Like I could graph this and see then where the graph crosses the x-axis. But the process is the same. If I turn that y into 0, then I have 3x squared plus 15 equals 0, which is exactly what this is right here. So what we're doing on this page is that basically the same thing, except we're moving from graphing to using just algebra. And that's kind of what the rest of the chapter is about, is using algebra to solve equations that look like this rather than having to graph, because graphing really is kind of a long process. So we can also solve quadratic equations that look like this by taking the square root of both sides. We haven't worked with square root a whole lot yet this year. We did a little bit earlier in the year. We're going to do it somewhat now, and then some more as the chapter goes on, and then chapter 10 we're using square root quite a bit. But when you take the square root of both sides, you have to include plus or minus, because when you take the square root of both sides of an equation, like for example, if I have something squared equals 4, what could the x be? Give me a number that works. 2 squared is 4. Is there another number that works? Negative 2 squared is 4. So both positive 2 and negative 2 work for this. So when I take the square root of both sides of an equation, the square root of x squared is just x equals the square root of 4 is 2, but I have to say plus or minus because both of those numbers actually make the equation true. Okay? That's what this right here is saying. When you take the square root of both sides of an equation, you have to include plus or minus because the positive version of 2 and also the negative version of 2 work for the equation. Okay? That's one of the trickiest things. You can lose points on a quiz or a test if you leave off the plus or minus, so you have to remember that. All right, let me get this out of the way, and let's take a look at that first problem. X squared equals 81. What could we do to solve this equation? Square root. So we're trying to think of the number that times itself gives you 81. What is it? 9. So I write on the left side the square root of x squared, which is just x, equals the square root of 81, which is 9, but I have to include the plus or minus because positive 9 or negative 9 will make this equation true. So this is my answer right here. Second one. Now this one looks a little bit different than this one, but what could I do here? Notice how this one looked. I had just x squared and I had the number on the other side. Do I have that going on here? No, so what could I do? Yeah, add the 36 to both sides to get the variable by itself, and that gives me m squared equals positive 36. Now we can square root both sides. What do I get on the left side? Just m equals, yeah, the number that times itself gives you 36. The number we need there is 6, but we need to say plus or minus on it. So there's your answer. One extra step that time, but it's not that big of a deal to do. So what should we do on the next one? Notice each time we're like adding one extra step. So what should we do first? Add the 75 to both sides. Good. So what does that give me? 3x squared equals 75. Now what should we do next? Yeah, you don't want to square root it now. You want to divide by that 3. Because over here we had just m squared. We had just x squared. So on this one we want just x squared. So divide both sides by 3. And that gives me what? X squared equals 25. And 25 is a perfect square, which is great. So what can we do now? Square root both sides, and we have x equals plus or minus 5. There's your answer. By the way, let's check that. So if I take positive 5 and I plug it in, positive 5 squared is 25, times 3 is 75, and then 75 minus 75 is 0. If I take the negative case, then I have negative 5 squared, which is positive 25, times 3 is 75, and then 75 minus 75 is 0. So both of these answers do work. So you do have to find both answers. You got to say plus or minus. Okay, the bottom two are for you. Go ahead. What's first on this one? Subtract 15. 3x squared equals negative 15. Now what? Divide both sides by 3 and you get x squared equals negative 5. Now what? There's a problem here. We need a number that times itself gives me negative 5. Is there a number that does that? Huh? No real, what? No real solution, yeah. So the answer here is that guy. So if you're doing these problems and you wind up with a situation where you're trying to take the square root of a negative number, you can't. There is no square root of a negative number. It's an imaginary solution. So that's your first little glimpse at an imaginary number right there. It actually is imaginary. So we say no real solution here, and that's why we draw that symbol. On the second one, what do we do? Subtract 16 from both sides, and we have 4d squared equals 0. Now what? Divide both sides by 4, and we have d squared equals 0. Now what? Huh? Okay, square root both sides, and we have d equals, what's the square root of 0? Yeah, what number times itself gives you 0? 0. 0 times 0 is 0. So the answer is d equals 0. We only get one solution there. I could write plus or minus 0, but is positive 0 different than negative 0? Nope. It is the exact same answer. So there's only one answer there. So we have two solutions, two solutions, two solutions. Just like those parabolas that cross the x-axis twice. We have no solution, just like a parabola that does what? Doesn't cross the x-axis. And we have one solution, just like a parabola that has what touching the x-axis? The vertex, yeah. So these are the same thing. We're just not graphing them. And we can only do this when all you have is the x squared term and the constant term. If the x term is there, the like x squared plus bx plus c, if that bx term is there, then you can't do what we did on this page. That's something for a later section. So that's the idea. Let's do this last problem here quickly. We have an aquarium being designed for a new exhibit to showcase tropical fish. The exhibit will include a tank that is rectangular prism with a length L that is twice the width W. The volume of the tank is 420 feet cubed. What is the width of the tank to the nearest tenth of a foot? Well, it says it is a rectangular prism, and I need to find the volume. It says the volume of the tank. How do I find the volume of a rectangular prism like that? You guys know? What? Length times width times height. Yes. So volume equals length times width times height. Now they told us the volume, it's 420. And then they told us that the length is twice the width, which means that the length is 2 times the width. So I can substitute that right there. And then the height is what? It's 3. Yeah, they got the 3 sitting right there. So I can write 420, because that's what they told me the volume is equal to the length, which they said was 2 times the width, so 2W, times the width, which is W, times the height, which is 3. So now I have 3 times 2 times W times W. 420 equals 6W squared. 3 times 2 is 6. W times W is W squared. Now what? I want to solve for W. So divide both sides by 6. Yeah, we want to get the W squared by itself. So divide both sides by 6, and that gives me 70 equals W squared. Now what? Square root both sides. And we get what? What is the square root of 70? You get W equals 8 point what? 3 what? Oh, 8.3666. But the problem says to the nearest tenth of a foot, so we're going to round that. We're going to call it W equals 8 point what? 4 feet. And that's how wide that aquarium is, 8.4 feet wide, 3 feet tall. And then from there we could figure out the length. It doesn't ask us to, but all we'd have to do to figure out the length is take that 8.4 and plug it in right here. 2 times 8.4 would be 16.8 feet long. So it's a pretty big aquarium. But that's how you do a problem like this. You got to think of the formula first, then substitute in the stuff that they gave you, then simplify it down, then solve. So there's a homework problem that's kind of like that. Do one